Thank you, Jack. Thank you all for coming. So just a prefatory note, while I'll focus on the work of Jeff Koons mainly, the incredible resonance with the processes and strategies of both Charles Ray and Katharina Fritsch, I think is something we can discuss as a group. One of a kind. In 2007, Charles Ray intricately replicated an entire tree trunk he had found in California in hand-carved precious Japanese cypress, which you see here. In 2010, Katharina Fritsch took a small model of a cock and produced a gigantic version of it in cast and 3D printed polyester resin for Trafalgar Square in London, which you see here. In 2000, Jeff Koons reproduced a store-bought balloon as an enormous, perfectly puckered, mirror-polished stainless steel sculpture, and you see it at the tail end of its fabrication here. These artists and their curious forms of reproduction are always slightly ahead of us. Koons, for example, has become famous for taking our own visual and material world and reproducing it, giving birth to it, as he would say, literally making it again. But his reality is enhanced. A small porcelain tchotchke will be scaled up to monumental height and precision milled in the world's pinkest marble. A balloon toy becomes bigger, brighter, and finer than it ever was, a Terminator chromed version of its formerly humble rubber self. The result is an entity as alien as it is familiar. All this is at once thrilling and unnerving. For what is transformed in these works is not simply size or material value, but materiality itself. Over the course of his career, Koons has increasingly amped up the technological ambition and complexity of his production, so that his fabrication standards now easily exceed those of advanced industry, whether aerospace or military. Beginning with the replication of an existing ready-made, he has arrived at a set of breathtakingly sophisticated and ever-evolving processes. In other words, he has transfigured the mode of industrial production by which that ready-made was originally realized. Today, more than 100 employees spend countless man-hours powering the Koons studio, researching, coding, rendering, engineering, laser cutting, polishing. But both the effort and the outcome remain mysterious. What type of thing, exactly, is Koons making now? First, these things begin with data. For more than a decade, Koons has employed various modes of 3D digital scanning to capture the qualities of an object or an image, like a balloon dog. That scanned information is then deployed to generate another form, often much larger, a mold, a machined stone shape, a foam model. The artist began with various forms of scanning that use light, such as laser scanning. But that technology, he found, had serious limitations. There were still areas, minuscule crevices, holes, grooves, twists, that the light could not reach. And it had trouble with translucent or reflective materials. One could not get a completely accurate reading. Or, more precisely, one could not get a reading that was accurate enough for Koons for his highly specific purposes. He would have had to infer the missing information, a lack magnified by having to enlarge the model, and a liberty that violated Koons' stated desire to reduce the subjective as much as possible, to achieve the utmost objectivity, as he calls it. This zeal seemingly drove Koons, about 8 years ago, to pursue an even more specialized mode of 3D scanning, the computed tomography, or CT scan. The CT scan uses X-rays, so it can penetrate surfaces that light cannot. It shows you inside and out, the recesses, contortions, the core of a thing. And the artist says, quote, it gives you every data point. CT scanning is primarily used for medical imaging, for the intricate geometries of organic matter. But Koons did not want to map a gland or a nerve. Instead, he would use the higher than high-tech process for other kinds of stunningly irregular geometry. the wrinkles and seams of a miniature wax toy, which he then reproduced in 3 tons of granite, polished to look exactly like the soft sheen of wax, and this is gorilla. Or the puckered plastic of an inflatable Hulk doll, or a duck pool toy, which you see here. Or the rendered netting of a miniature pink porcelain ballerina's tutu. That last item's lace, in particular, is the kind of nonlinear volume that pushes the limits of scanning technology. And you see a foam maquette here that was milled, but this is just a sample of that lace. It's a warping, erratic tangle of divots and swells. And such a volume is, surprisingly, more complex than most industrial parts or tools, which rely on smooth surfaces and simple, iterable shapes. Corporations generally can't afford to use CT scanning in this way and at this scale. In fact, good engineering stays away from complexity. Koons goes after it. Today, a 3D scan is commonly rendered as a point cloud, a constellation of one-dimensional points mapping a surface. But because a CT scan penetrates surfaces, it provides more than a point cloud. It can produce actual volumetric data, not just an outer skin, but everything inside. And that information can now be imaged as an unprecedented kind of 3-dimensional rendering, a voxel, or volumetric pixel, the use of which Koons' studio is currently exploring today. And you see a voxel rendering here. While a point is merely a set of spatial coordinates, and a normal pixel has height and width, a voxel has, very simply, height, width, and depth. It can also capture density, tensility, and color. The voxel carries more and richer information about a volume than any set of point samples or polygonal meshes. In addition to medical research, voxels are a unit of choice for the video gaming animation industry and for Hollywood blockbusters. But even these industry standards are not good enough for Koons, who seeks to convert a set of voxels back into a real, refined thing, bringing the 3-dimensional into the 2-dimensional and back again. In this scenario, the 3D rendering can't remain a screen image in a game or a movie, however extravagantly illusionistic. It must undergo still further transformation, from code to instruction to actual physical mass. The studio doesn't do it alone either. Today, the Koons staff is pairing with the likes of the Center for Bits and Atoms at MIT, headed by the fabrication pioneer Neil Gershenfeld, which takes as its mission the digitization of materials. Koons' studio has worked with Gershenfeld's lab to experiment with voxelization, collaboratively developing new tools, new software, and new workflows, methods of planning, thinking, and doing that change every step normally taken to render and produce a 3-dimensional object. For the next conversion is near Eucharistic. Koons' studio must translate the gargantuan amounts of data garnered via the CT scan into a tremendously complex set of digital instructions or tool paths, charting the routes that their very specifically contracted machine tool will take to form that 3D rendering in actual physical material. In other words, an abstract mathematical surface must become an engineering structure, a thing to be worked. So the involutions of the ballerina's lace, for instance, must be converted into innumerable tool paths for carving away interlocking honeycomb topologies of jagged, twisting, and chambered forms with extreme precision. At this stage, polyurethane maquettes have been made, and you see one being milled here, but the final object is yet to be produced, a giant pink marble confection with all the manifold space and mathematical complexity of a network. It's this combination of geometric complexity, precision, scale, optical finish, volumetric CT scanning, and multi-axis milling that makes Koons' endeavor so singular. The artist is flouting the normal engineering workflows at every step of the process, breaking them at every turn. And the machining, finishing, and construction aspects, which I won't go into here, are equally astonishing. What we see when we look at a Koons is the look of infinite customization. He has customized not only matter and information, but systems themselves. Countless other artists and architects have dabbled in each new wave of design and construction software. But for many, the work lapses into tautology. I make this because the software can do it. Koons, on the other hand, asks, what can I make this software do? How can I make software or machinery that does exactly what I want? Such processes change the definition of making. They represent the complete reversal of the serial production of minimalism and the legacy of sculptural multiples that preceded it. Koons's brand of customization increasingly rejects mechanical standardization and regularity in favor of complexity, idiosyncrasy, and irregularity. And it points, in fact, to the future of digital fabrication. This is what Gershenfeld's lab is hunting and what Koons's production portends. The digitization of both manufacture and material, the generation of systems that can be assembled and reassembled, recombinant and resized. As Gershenfeld argues, the real revolution in digital fabrication, as in computing, is personalization, ranging from the mass production of non-standard, customized objects to the ability to create one bespoke thing for precisely one customer on demand. Rather than mass-produce series of identical items, these new non-standard modes of design and manufacturing may mass-produce sets whose constituent objects do not physically resemble one another, that are similar only because their production shares some of the same algorithms, design parameters, or machines. And even these parameters might be broken with the advent of big data, allowing production that doesn't seem to follow any rules at all, just the creation of infinite variation via pure number crunching, case by case, for each anomalous and eccentric shape. Non-standard production changes our understanding of likeness, resemblance, and similitude. It shifts from physical likeness to algorithmic likeness. Likeness itself may even fall away. Koons's work forces the new digital customization into confrontation with the industrial era act of making an identical copy. The artist's sculptures are haunted by the ready-made, yet they are projections of the made-to-order. The industrially reproduced ready-made begins to look quaint, whereas Koons's custom-made pieces appear particular, almost organic, the result of the seemingly irreconcilable states of handicraft and algorithm, human cogitation and machine computation, immediacy and complexity that the artist brings together. And maybe this is why Koons's objects appear molten, buoyant, ephemeral, their lapidary surfaces nearly bursting or dissolving into something else. They show us the commodity not as it is or how it was, but how it will be. Thank you.